So now let's figure out exactly how much arachidonic acid we need to burn to warm a 600 kilogram bear from 2 degrees to 25 degrees Celsius. So the first thing we need to do in this case is figure out how much heat is necessary to warm that bear from 2 degrees to 25 degrees. It's just going to be equal to the total heat capacity times the change in temperature. Well, the change in temperature, easily enough, is 25 degrees minus 2 degrees Celsius. So that's 23 degrees Celsius, which when we are talking about temperature changes, the change in temperature in degrees Celsius is actually the same as the change in temperature in kelvins. All right, we don't have to worry about the 273 degree factor. Let me just write that down. Delta T in degrees Celsius is equal to delta T in kelvins. All right, so that's delta T. What's C total? Well, we are given the heat capacity per Kelvin per kilogram as 4.184 kilojoules per Kelvin per kilogram. All right, so what we need to do then is multiply it by the kilograms to get the total heat capacity. So the total heat capacity is 4.184 times the mass of the bear, which is 600 kilograms. The kilograms are going to cancel out, and we're going to get a value of 2,510 kilojoules per Kelvin. All right, so that's our total heat capacity. So therefore, the delta H that we need, the heat that we need to warm the bear, is going to be 2510 kilojoules per Kelvin times 23 kelvins. All right, so that's what we're going to need to heat the bear. And that is equal to 57,739 kilojoules. And again, if we're going to round it off to just 2 sig figs, because that's what we've got here, it would be 5.7, I'm putting this in scientific notation, times 10 to the 4th kilojoules. All right, so that's how much heat we need to keep warm the bear from 2 degrees to 23 degrees. Now we need to figure out how much arachidonic acid we need to burn. And again, if we go back to our calculation earlier, we found that we would generate 11,806 kilojoules per mole in that case. And so for 1 mole, so we need to figure out basically how many moles. So that's the next question. How many moles do we need? And then once we know how many moles, we can calculate the mass. All right. Well, so how are we going to do that? If I take my, and again, using dimensional analysis, what I've got is 5.7 times 10 to the 4th kilojoules. All right. And I know that my value is 11,806 per mole. So I'm going to use dimensional analysis. All right, so we get a value for the number of moles of 4.89. And again, I'm not worried too much about sig figs at this point. 4.89 moles for the number of moles of arachidonic acid that need to be burned in order to warm the bear from 2 degrees Celsius to 25 degrees Celsius. All right, so now we need to figure out the mass. So we got to go back and look at our formula for arachidonic acid, which is C20H32O2. All right, so we can add all of that up easily enough. And what we're going to get for our molar mass here is going to be 304.47 grams per mole. All right, so 304.47 grams per mole, so that should be fairly simple now to calculate the mass. We're just going to take the number of moles, 4.89 moles, times our molar mass of 304.47 grams per mole. Forgot to write the mole there, and the moles will cancel out. We're going to have grams, and so we're going to get 1.49 times 10 to the third grams of arachidonic acid. So 1,490 grams of arachidonic acid. It needs to be burned to warm that 600 kilogram bear from 2 degrees to 25 degrees. This problem was a little bit more complex than some of the other things that we've looked at, but I hope this is understandable. Certainly, if you have any questions, let me know.